There are more than 1,000 active volcanoes on Earth. About 50 erupt every year. Many are well known. Vesuvius, Pinatubo, Mount St. Helens. But these fire-breathing mountains are dwarfed by a type of volcano discovered only in the last few decades. A supervolcano. Now, evidence of one of the most powerful of these super eruptions is emerging in a most unlikely place. Here, on a flat, icy tundra, less than 1,000 miles from the North Pole, the mystery begins. While on a routine mission, researchers for the Greenland Ice Sheet Project uncover the first clue. They are searching for a place to drill into the ice. This ice is an accumulation of more than 100,000 years of snowfall. As snowflakes form, they capture chemicals in the atmosphere. Over time, the snow is compressed into this ice sheet, now a mile thick. To read the chemical history, the researchers drill ice cores. The deeper they drill, the further back in time they go. Climatologist Greg Zielinski is an expert at finding secrets frozen in this ancient ice. By analyzing the composition of each annual layer in the ice core, he finds tiny chemical fluctuations that correspond to periodic shifts in temperature and climate. One day, Zielinski gets the shock of a lifetime. Something in the ice that defies all logic.
When we got back to about 75,000 years ago, we found a particular piece of ice that gave us information that was just so exciting.
What Zielinski sees is a huge leap in a particular noxious chemical, concentrated sulfuric acid.
The concentration of the sulfuric acid was on the order of 2,000 to 4,000 megatons. That's a lot. That's a lot of material to be up into the atmosphere.
In fact, it's up to 25 times more than all industrial sulfuric acid pollution produced over an entire year on Earth today. This line on the graph hints at a global event of unprecedented scale, 75,000 years ago. Billions of tons of sulfuric acid somehow found its way into the Earth's atmosphere and blanketed the planet in a poisonous yellow haze. Where did it all come from? Something extraordinary must have taken place.
The more I looked at the results, I knew we were looking at something that was just cataclysmic.
Zielinski and his team know something significant happened to the Earth 75,000 years ago. But what? Thousands of miles away, another mysterious clue arises in an entirely different place. The deep ocean. Like Zielinski, geologist Mike Rampino studies the history of our planet's climate. But instead of deciphering ice cores, Rampino investigates ocean cores, layers of sediment drilled from the sea bottom.
In ocean cores that we use like this one, you can often see the changes in temperature and climate by changes in color in the core.
Rampino can trace shifts in the Earth's climate from something in the cores. The shells of tiny sea creatures called foraminifera. While forming their shells, these minute creatures absorb oxygen from the seawater. But that oxygen can be one of two forms, or isotopes, that have different mass. Lighter oxygen-16, or heavier oxygen-18, which is more abundant in colder water. By measuring the ratio of these two forms of oxygen, Rampino can calculate ocean temperatures over many thousands of years with amazing precision. Rampino analyzes ocean cores from all over the globe and finds that the oxygen ratios in the shells of foraminifera remain fairly constant. That means ocean temperatures also have remained constant for long periods of time. But one day, Rampino sees something bizarre in the oxygen ratios. A point in the Earth's history when ocean temperatures plummeted.
At the time, I thought, there's something wrong here. This isn't normal. This isn't the way climate usually works. It usually works on a much slower, more steady basis.
Rampino's seashells are telling him that ocean temperatures dropped nearly 10 degrees Fahrenheit over just a few thousand years, which in the Earth's 4.5 billion year history is the blink of an eye.
The temperature change that we saw in these deep-sea core records was something like 5 or 6 degrees Celsius. That's 10 degrees or more Fahrenheit, not over 100,000 years or even 10,000 years, but over just a few thousand years. Now, climatically, that's very surprising. That's very, very fast. That's very catastrophic.
To Rampino, the cooling seemed like an unusually sudden onset of an ice age.
It was like flipping the switch on the global climate system from hot to cold.
Then Rampino calculated the date of this steep drop in the world's ocean temperatures. It was 75,000 years ago. The same time Zelinsky's ice cores showed massive amounts of sulfuric acid in the atmosphere. The two scientists, completely unaware of each other's work, hit upon two different anomalies linked by a single date.
I was finding a cooling event at 75,000 years ago, and Greg, I later found out, was finding an increase in the chemistry of the ice cores 75,000 years ago. And we got together and realized that we had the same problem.
When you can look at something from different angles and see the same major result, you know you have found something that was huge, something that was a major force on the Earth's climate system.
Only a few natural phenomena could have created such a powerful force. One is an asteroid. Asteroid impacts blast debris into the atmosphere that blocks the sun's rays and cools the planet. But those impacts do not produce sulfuric acid. There is another possibility. Volcanic eruptions are known to pollute the atmosphere with sulfuric acid. But there's still a problem. Even history's biggest eruptions produced only a tiny fraction of the sulfuric acid Greg Zelinsky found. For an eruption to have cooled the climate and poisoned the atmosphere worldwide, it had to have been thousands of times more powerful than any in recorded history. Could such a volcano have ever existed? Without knowing it, another scientist is about to step into the mystery.